Hi and hello dear friends, welcome back once again to our channel Vagai Academy of Mathematics, and this playlist is where you can find video lessons for CBSE class 11 applied mathematics. This session we are about to solve exercise 5.1, and that is from the concept of sets and relations. And of course this is going to be the first exercise of this concept, sets and relations. And let's see about what are all the things, based on what are all the concepts inside this sets and relations, we have problems here in this exercise. Yes? Yeah, come on. So we have all fundamentals of sets. Okay, all these problems are just going to be based on the basics, the fundamentals of sets only. So it is not going to be any of advanced things about sets. Since this being the first exercise, we just got only some basics about sets. Let's just quickly see under what are all the concepts we get questions here. So if you see here, sets and elements, we have questions based on what about a set and what about the elements here, and what elements will be belonging to that set and what elements will not belong to that set. Based on this we will be having questions. Okay, and next coming here, another important part, if you see the second thing, so we will have questions based on the representation of a set. What do you mean by representation of a set? So given defined any set, how do we represent it? So how do we define it? Okay, so based on that is what we have some two important forms here. They are what we call it to be the roster form and the set builder form. Okay, so we will have questions based on the representation of sets also. So based on this one we have questions. Next, coming to the cardinal number of a set. Okay, they will be defining, or they will be giving you some set, and what we have to do from there is we have to get what is the cardinal number of that set. What do I mean by cardinal number? It's very simple to understand. Given any set, how many elements you have there. Okay, that's what we call it to be the cardinal number of the set. Based on that we have questions. And last we have questions based on different types of sets. Okay, so finite set, singleton set, null set, infinite set, everything based on this also we will be having questions. So all these things, when we work the problems, you can very easily understand. Okay, let me not define each and everything here itself, it will be confusing you, or it will complicate the thing. When we try doing the problems itself, you can very well easily understand each of these concepts. Okay, yes, fine. Yeah, this is the objective of this session, and yes, let's begin solving the problems of this exercise. Here is our first question. Let's see what is given here. If set A is equal to 3, 5, 7, 9, 11. That is, here we have got a set A, and it contains these elements 3, 5, 7, 9, 11. That means there are 5 numbers here. Okay. Then write which of the following are true, and if a statement is not true, mention why. So it's going to be a very simple question. So our first question, so here we have just given a set, and we have to see which of the following statements are true or false. And if the statement is not true, that is if the statement is false, we will have to mention the reason. This is what we are asked to do here in this first question. So as I told, it's a very simple question, and if you look at these statements, all these statements are just it is based on the concept of the belongingness. Okay, yes. So whether a given element or given part of this set is belongs to that set or not, this is what we are asked to find. Okay, so you can see this symbol, you can see the strange symbol here, right? That symbol actually denotes the meaning belongs to. Okay, yes. So if you want, I can even write it and show you. Okay, so if you write like this means we call this as, or we read this as belongs to. Okay, so yes, and same way, if the symbol is put here and if it is given a strike sign, okay, then we read it as not belongs to. Okay, not belongs to. So this is how we read it. Okay, yes, I hope it is very clear to you. And now we'll just quickly just examine the statements one by one. Okay, coming to the first statement, we have 3 and the defined sign which is called belongs to A. Okay, that is, we have to read it. How we have to read it? We have to read it like 3 belongs to A. Now we have to check whether this first statement is true or false. Okay, yes, you'll just see this 3 is an element here, is it or not? So we'll check whether that element 3 is inside that set A or not. This is what we have to check, because it is given 3 belongs to that set A. That means we have to check whether this element 3 is belonging to, or whether it is inside or not. This is what we have to check. It's very easy to say for us, right? See here, the 3 is present inside that set A. So in that case, this first statement is no doubt, undoubtedly, it is true only. So let me write true. Okay, I'm just going to write T. T represents it's true. Okay. Same way, come to the second statement. Here it is given the elements 5, 9 belongs to A. We'll just check whether these elements belong to A or not. We'll just check it and see. Yeah, if you see here, yeah, this 5 is also present inside this A and this 9 is also present inside this A. So no doubt, that means these two elements are present here. That means the second statement is also true. I'm writing T here. Fine, yes. Coming to the third statement. Okay, third statement says 8, the element 8 does not belongs to A. That is 8 not belongs to A. This is what they are coming to say here. So that means here they are coming to say that element 8 is not present in A. We will check the elements of A. Do you find A here, 8 here? No, it is not here, right? 8 is not here. That means this is again true only. Yeah, this is true only. Why? Because they are not writing here, they are not defining here that 8 belongs to A. If they have defined 8 belongs to A, then definitely this statement would have gone false. But here they are defining 8 does not belongs to A. That is indeed it's true only, right? 8 is not belonging to that set A. It is not belongs to. I mean that 8 is not present inside that set A. It is true only. So I am writing it to be true. Okay, all right. Yeah, coming to the next one, fourth statement. Here we have the element 9 does not belongs to A. Okay, 9 is not belonging to A. We'll just check here, but it is seen here that that element 9 is present inside that A. Is it or not? So that means 9 belongs to A is what is true, but here it is given 9 is not belonging to A. That means this is sure a false statement. Okay. Why it is false? We have to define the reason, mention the reason also. So 9 does not belongs to A is false. Why? Why? Because like 9 belongs to A. This is what is correct. Okay. As per the given question, as per how the element, the set A is defined, the elements what we say inside, 9 is belonging to A. But here it is given 9 does not belongs to A. That means this is false. Yes. Next, coming to the next one, fifth statement. Here it says the set, be careful here, the set with 3 belongs to A. Okay, so far for the first 4 statements, everything represented here are only elements they have given. But this time you see statement 5 here they have used the braces. That is, here this is not simply an element 3, this is 3 which is present inside another set. Okay, this is a 3 present inside a set. So it is given that the set that contains 3 belongs to A. But is it true here? Do we have something like that? No, we don't have like that. We don't have a set which has 3 inside A. We have just got the element 3 here. Okay, so in that case only this 3 belongs to A, not this set that contains 3. It is not belonging to A. So in that case, this is also a false statement only. We'll define the reason. Okay, why? Because only this 3 belongs to A. Only this 3 belongs to A, not this set that containing 3. This is not belonging to A. Why? Because once you insert it inside a braces, what happens is this is no more an element. This becomes a set. Okay, so this means this becomes a set. Okay, I'll just write it separately. So it says that A contains another set inside. So the meaning will go like that, but it is not true as per it is defined in the question. So that means this is also, statement 5 is also, it is false only. Okay, yeah, coming to the last one here we have again a very similar thing what we had the previous fifth one. Here we have got the set that contains 5 and 7 belongs to A. Here again the same reason, 5 and 7, the elements are belonging to the set A, but the set that containing 5 and 7, it is not belonging to A. Okay, again this statement is also false only. Why? Because I can surely say 5, 7 belongs to A. This is correct. But I can't say this 5, 7, the set that contains 5, 7 belongs to A. I can never tell this. So this is also wrong and this is also wrong. Okay, so that means this belongs to A. It is wrong. That is, it is not belongs to A only correct. And here also this 5, 7 does not belongs to A. That is only correct. But here they are given this belongs to A. That means this is false only. Okay. Yeah, so the first question, we have solved all the subdivisions here, and it is very simple idea only. So we'll just have to examine, or we'll have to test whether a given element or a given set belongs to a particular another set. This is what we are asked to do here, and I hope you are able to follow all these questions. You are able to get the answers also. Yes, you are able to understand, I think. Yes, now let's move on to the next question. Coming to the second question, here we have use the roster method to represent the following sets. So that is, here we are defined certain sets here, and we have to represent them in the form of roster method. This is what is asked in the question. Okay, so as I said in the beginning itself, we have got majorly two main methods or two ways to represent any set. Okay, one is this roster method, and the other one is something called set builder form. Okay, so here as of now, let us just discuss about what about this roster method, or how to represent any set in terms of roster method. That we will see first. Okay, it is a very simple way of representing a set, where we'll have to represent, or we'll have to list the elements inside the braces. Okay, what are all the elements that are present inside that set, we'll have to just put them inside the braces, and to separate each of those elements, we'll just put a comma mark. Okay, so this is how we'll have to define any set in terms of this roster method, and we are going to express these sets in terms of that roster method only. How we are going to do that, let us see now. So let's work out the subdivisions one by one. We have got more subdivisions here, so we are going to do them part by part. Okay, first 4 subdivisions here I have taken here, and we'll just move on with the other also as part subdivisions. Okay, yeah, coming to the first subdivision here, our set here is the counting numbers. Okay, what do you mean by counting numbers? Counting numbers are simply natural numbers. Okay, so natural numbers we very well know, right? 1, 2, 3, 4, it starts from 1, and we'll have to account all the whole numbers. Okay, 1, 2, 3, 4, 5, these are what we call it to be natural numbers, or in simple words, how we count numbers. So we count with 1, 2, 3 and so on only, right? This numbers is what we call it to be counting numbers. Okay, counting numbers which are multiples of 6. Okay, which are multiples of 6 and less than 50. Okay, so we have to frame this set like what? We have to frame this set as counting numbers, and we should take the multiples of 6. What do you mean by multiples of 6? Multiples of 6 are nothing but numbers which come in 6 tables. That's it. Okay, so that means we can start from which number? 6 ones are 6. From here we can start. Next, what number we will have? 6 twos are 12. Next is 6 threes are 18, and so on. We have to go like this. But other condition, what it says? And less than 50. Okay, so we'll have to account, or we'll have to list all, what are all the elements? All the multiples of 6, but it should be less than 50. Okay, so we'll continue till we reach less than 50, the maximum number. Till that we'll have to go. Okay, next 6 fours are 24 will come, 6 fives are 30, 6 six are 36, 6 sevens are 42, 6 eights are will be 48, and 6 nines are will be 54. And that is not going to be less than 50, right? So that means the last number that is less than 50 is going to be this 48 only. So that means our first subdivision, the set corresponds to this set only, and also we have represented our set in terms of this roster method. Okay, so this is what we call it to be roster method. So we take braces, and we will list all the elements inside that braces, and we'll just separate by comma marks. We'll put comma marks to separate it. Okay, 6, 12, 18. Writing and set in this way is what we call it to be roster method. Okay, I hope it is clear to you. Now the same way we are going to define all the other sets also. Okay, coming to the second subdivision here the question is the fractions. Okay, so that means the second question we are going to have fractions, the fractions whose numerator is 1. So that means this set is going to contain some fractions only. The fractions whose numerator is 1, note it. Okay, the fractions numerator, every fraction that is going to appear inside this set, it is going to be, the numerator is going to be 1, and whose denominator is a counting number less than 10. So be careful with this. Numerator is 1, that is very clear. And denominator, what they are telling about the denominator? Denominator is a counting number. Again, it comes counting number. Okay, so counting numbers means we'll have to take natural numbers only. That is starting from 1, 2, 3 and so on. Okay, it is a natural counting number less than 10. This is what we have defined. Okay, so that means how we have to take the elements of this set, how we have to represent it. So it's going to be simple. So the first element will be what is the first counting number? First counting number is 1, correct? 1 is the first counting number. In that way, what we have to do now, numerator is 1 and denominator of the first element is also 1. So that means the first element will be 1 by 1, that is going to be 1 only. Comma. Next, the second element. What will be the second element? Second element will be, again the numerator is going to be 1 only, but this time 1 by, what is the next counting number? Next counting number is 2. So 1 by 2 is the next element. Okay, put comma. What about the third element? Third element, again the numerator will be 1. Numerator is always 1 only. Okay, that is how they have defined. Numerator is 1, they are defined, but denominator is the counting number less than 10. Okay, this is what they have defined. Okay, so next is 1 by, what is the next counting number? It will be 3. So it will be going like this. Okay, next number will be 1 by 4, next 1 by 5, 1 by 6, comma 1 by 7, comma 1 by 8. Next, what will be the next number? It will be 1 by 9. And what about the next number? Next number, if I try to put here, we will get 1 by 10. But as per the condition, it is not allowed. Why? Because they have clearly defined here, like denominator should be a counting number less than 10. Okay, so that means up to 9 only we are allowed to take here. So that means this set elements are going to be this set of elements only, like these are going to be the collection of elements that we will have inside this set. So 1 by 1, from 1 by 1 to 1 by 9 we have all the elements. Okay, yes, fine. Okay, and next is, since this is 1 by 1 only, I am just directly writing it to be 1 itself. Okay, and the others are going to be fractions only. Yes, okay, so yeah, this is the way we have this elements. Okay, this set to be defined here, and yeah, completed. Now coming to the third subdivision here of this question. So third subdivision, let us see how the way they have defined this set here. Okay, let's be careful in analyzing it. Okay, so they are defined it to be the set that contains x. Okay, set that contains x such that, okay, they have written a colon here, right? They have given a colon here. It is, this colon should be read as such that, okay, such that x belongs to a natural number, that is x is a natural number, and at the same time x is a prime factor of 84. So this strange way they have defined. Okay, actually this way of defining a set is what we call it to be a set builder form. Okay, this is what we call it to be set builder form. Okay, so I told that the starting itself, right, there are two main methods. One is roster form, the other one is set builder form. That set builder form is what is this one. Okay, so how we have to read it? Once again I'll just revise it. So set of all elements x such that x is a natural number and x is a prime factor of 84. This is what we are given here. So that means this set will contain what are all the elements? It's simple to see, very simple. Okay, that means this set will contain all numbers x in such a way that x is a natural number. X is a natural number, we very well know. Okay, counting number, natural number, everything is the same. Okay, 1, 2, 3, 4 and so on. And also x is a prime factor of 84 they have given here. So what do you mean by prime factor of 84? That means we have to check the factors of 84. Among them we have to pick only the prime numbers. This is what we are asked to do here. Okay, so in that case let's do a simple thing first of all. Okay, let's do a very simple thing now. So I'm going to take this number 84 because we need the prime factors of this 84 only, right? So in that case let's just take 84. I'm going to just factorize this 84. Okay, I'm going to factorize it. Okay, by what numbers we will try to factorize? We will only use prime numbers. Why? Because we just asked to take only the prime factor, right? So let's use only prime numbers here. So if you try to do that, we'll be having first prime number will be 2, right? So 84, let's divide it by 2, we'll get 42. Again I can divide by 2, we'll be getting 21. Next 2 is not possible. We can go for the next prime number. Next is 3. 3 7s are 21. So that means 84, what are all the factors we have? We have 2, 2, 3 and 7. But we are defining a set here, so that means we are not allowed to repeat the numbers. Okay, the elements inside a set, it should not be repeated. So if I'm asked to find only the prime factors of this 84, what we are supposed to do now? We have to just take only the numbers, those prime factors without repetition. So in that case we will have only 1 2 here. So 2 comma, and then we'll have 1 3 and then we'll have 1 7. So that means these numbers 2, 3 and 7. I mean the set that contains 2, 3 and 7 are what? The elements of this defined set that we see in subdivision 3. Okay, I hope it is clear to you. So once again, I'll quickly revise. X set of all elements. The set contains set of all values x. Such that x is a natural number. Obviously, these are natural numbers only. And also, x is a prime factor of 84. So for which only what I am doing here is I am separately factorizing this 84 and I am picking the prime factors. Okay, and at the same time, don't write 2 comma 2. That is not acceptable inside a set. Why? Because like inside a set, whenever we define a set, we should represent the elements of the set in a unique way. Okay, we should not repeat the elements. Okay, so 2, 3 and 7, these are going to be the elements in this set. Okay, all right. Yeah. Next, coming to the fourth subdivision, here we have set of odd integers lying between -4 and 8. So this is what we have here. So here this set we are asked to collect the set of odd integers. So we know what are odd integers, right? Then odd integers are nothing but the numbers which are not divisible, which are not perfectly divisible by 2. They are what we call it to be odd numbers. So odd integers between -4 and 8 we are asked to take. Okay, so that means we can quickly take it. Okay, so whether positive or negative, we know the condition what is an odd number or even number, anything we know. But here we are asked to take only the odd numbers. Okay, so it means between -4 and 8 we have to collect all odd integers. Okay, this is what we have to do. So start from this -4 itself. So -4, though it is negative, it is going to be an even number only. Okay, so that means after -4, what is the next number? It is going to be -3. What about -3? -3 is surely an odd integer only. Okay, so in that case I can take -3. What about the next odd integer? It is going to be nothing but -1. Okay, because we got the first number, right? We can just add 2 to 2. Okay, next one will be 1, next one will be 3, next one will be 5, and next one will be 7. And what about the next number? Next number, if I try to write, I will be getting 9, but we are asked to take odd numbers only between -4 and 8. Or technically talking, what we have to do? We have to take odd numbers which is between this range only. Okay, or otherwise I can tell more than, greater than -4 but less than 8. Okay, that collection only we are allowed to take here. So I am just collecting all the numbers here, all the elements here. So that means this set contains these elements. Okay, -3, -1, 1, 3, 5 and 7. Okay, these are going to be the elements of this set, and we have completed the first 4 subdivisions. Let's move on to the next one. Continuing the second question, next we have the 5th subdivision. Here the question is the set of all natural numbers x for which x plus 6 is less than 10. Okay, so the condition is very important. Set of all natural numbers x, that will be perfectly okay, and at the same time for which the value of x plus 6 should be less than 10. This is how they have defined this set here. So that means this set will have what kind of elements? What elements? You should take only natural numbers. Natural numbers in the sense, we can take what numbers? Natural numbers we will start from 1, correct? So 1, 2, 3, 4 and so on we can take, but it should satisfy this particular condition. Okay, the number what I am going to take, that number plus 6, the value should be less than 10. Okay, now shall we try one by one? So since it is accounting only for natural numbers, let us start from the first natural number from 1 itself. Okay, so if I consider that number 1, just think and see whether 1 plus 6, is it less than 10? Is it? So you can clearly check it and see, is it or not? So 1 plus 6, if you do, it will be 7. Yeah, obviously 7 is less than 10 only. That means you are perfectly allowed to take 1 inside this set. Okay, same way we'll go for the next element. If I take 2, so 2 plus 6 will be 8. Yeah, 8 is also less than 10 only. So I can very well take 2 also inside this set. Okay, next element, we'll just check for 3. 3 plus 6 will be 9. So 9 is also less than 10. That means we are allowed to take 9 also inside this set. Next, if I try for the next natural number, 4. So what about 4 plus 6? If I take x as 4, then x plus 6 will be 4 plus 6. That will be what? It will be 10. So is 10 less than 10? No, our condition is not satisfied. That means our set will have only these elements 1, 2 and 3. That's it. Okay, so that means this is going to be the answer for our 5th subdivision. Okay, I hope it is very clear to you. We have to carefully see what numbers we have to use, and at the same time we have to be very clear with the condition which is specified also. Okay, yes. So this is going to be the answer for our 5th subdivision. Go to the next one, 6th subdivision. Here we have the set of all integers. Okay, be careful here. The set of all integers. So the previous thing we have natural numbers. Okay, here we got natural numbers, but here this question we got integers. So what do you mean by integers? Integers in the sense, this time we are allowed to take 0 and also negative numbers. Okay, so hope you know the meaning of what about integers. Okay, the set of integers will be represented by the capital I or capital Z. That is how they will be using it. So here they have defined the set of integers. So that means we can take from minus infinity to plus infinity all the whole numbers. Okay, I mean, it should be if I want to be very clear, the numbers which is with no decimals. Okay, for example, from minus infinity till, okay, we can take minus 5, minus 4, minus 3, minus 2, minus 1, then 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. It runs till infinity. Okay, so this set of elements is what we call it to be the set of integers. Okay, now x is such an integer, and here what condition do we have here? Let's see that, for which x plus 6 is greater than 10. Okay, so here the condition is set of all integers x we have to take, and the condition is for which x plus 6 should be greater than 10. Okay, so this is what they have given here. So here that means we can take any negative number or 0 or even positive number we can take. Okay, yes, but we will just try to see what can be the least possible number that will satisfy this condition. Okay, yes, so we'll take the least possible number. Okay, for example, if you take x as 0, just for a sake I am telling, if you take x as 0, 0 plus 6 will be 6. Is 6 greater than 10? No, it is not greater. So that means in order to accomplish a number inside this set, what should happen? My answer for this x plus 6 should be at least 11. I hope you are able to understand the point. Why? Because it should be 11. Why it should be at least 11? Only then it will be greater than 10. That's why. Okay, so greater than 10 means strictly not 10 or less than 10. It should be strictly greater than 10. That means at least it should be 11. Okay, since we are using integers. Okay, so it means now you can think easily what number I can put here. Okay, so for what number if I put for x here, I will get x plus 6 as 11. You can easily visualize it. It will be 5. Correct? Okay, so it means x you can take it to be 5 here. So 5 plus 6 will be what? It will be 11, and obviously 11 is greater than 10. That means the first number I can place here inside this set itself will be this 5 only. I hope you are able to understand the reason. And now you can try any number which is less than 5 also. Can you try doing that? If you take x as 4, what will happen? You will get 10. That 10 is not greater than 10. And definitely if you take lesser numbers also, it will not satisfy. So the first number that would satisfy this condition will be 5 only. Okay, so x is equal to 5 only, it will satisfy first. So x equal to 5, it will be satisfying. And what about the next number? What if you take x as 6? So if you take x as 6, just check here, 6 plus 6 will be 12, and of course it is also greater than 10 only. What about 7? What about 8? What about 9? So that means it is again very clear that hereafter any number I take, it will always satisfy this condition. So that means this set can be defined in what way? 5, 6, 7, 8, 9, and it will be going so on and so on. Okay, yes, there's no limit here. We can't exactly tell how many elements are inside and what can be the last element. We can't tell that. Only thing what we can tell is like it will start from the integer 5 and it will take all the integers from starting from 5 and it will be going on. So this is what this set of elements are what we will be having inside this defined set that we see in this subdivision number 6. Okay, I hope it is clear to you. So it is 5 is the starting number. I told you the reason why it is, and it will be going and we can't end this. Why? Because hereafter any value we take it for x, it will always satisfy this condition which is given in the question. Okay, that's why. Okay, it is going like this. So this is the answer for this question. Coming to the 7th subdivision, here we have the set of all integers x for which x plus 6 is less than 10. Okay, so it is like quite exactly opposite of what we have here. Okay, like almost like opposite. Okay, so set of all integers x for which x plus 6 is less than 10. This is what they are asked. Okay, so here again let's try to predict what can be the least possible number. Okay, what can be the least possible number? Here again we have set of all integers. This is what we have, is it or not? So here we got set of all integers. So here again we are allowed to take negative numbers, 0 or positive numbers, but at the same time it should satisfy the condition. Okay, now let's just think of what can be the least possible number that will satisfy this. Now if you go think like that, it will not be that easy for you to find. Okay, so that means let's do a very interesting easy thing. Let's try to find what can be the greatest possible value that will satisfy this. Shall we? Yes. So now you just think of what number you can take for x such that x plus 6 will be less than 10, or in other words, if I want to be very precise, what value I can take for x such that this x plus 6 will be maximum 9, or it can be at most 9. That's all. Okay, why I am telling at most it can be 9? Why? Because only then it will be less than 10. It should not be even equal to 10. That is what is the point. Okay, so in that case I can take any value for x as far as it is going to be maximum 9 and not more than 9. In that way only I have to take. So that means what number I can take for x? I can take x to be equal to 3. Is it or not? Very easily you can visualize it. Okay, so 3 only I can take. That means what you can understand here? That means 3 is the largest possible number that you can place inside this set. Okay, so 3 will come to the last position. So 3 plus 6 will be 9, right? So 9 is less than 10. That means I can very well take 3 inside. And what you can tell? After 3, any other value if you try to put, I mean more than 3, any other value if you try to put, even if you take the next integer 4 itself, it won't satisfy this condition. Why? Because 4 plus 6 will be 10, which is not less than 10. Okay, so that means you can take a maximum 3 only for the value of x. And what about the lesser values? Lesser values you can take any lesser value, is it or not? Why? Because if you take x is equal to 2, I am taking the previous integer, can you try checking it? 2 plus 6 will be less than 10 only, is it or not? Because it's 2 plus 6 is 8, 8 is less than 10. And also I can take x as 1, 1 plus 6 is 7, 7 is less than 10 only. I can even take x as 0, that is also possible, right? 0 plus 6 is 6, 6 is less than 10 only. So that means it is very clear that any numbers hereafter I can take down the lesser side. Okay, it will always satisfy this condition. So that means I will have minus 1, minus 2 and so on. Okay, so that means for this set, what we have, what it is given defined in the question, for this set, what are all the elements you will have inside? You will have numbers or the integers starting from minus infinity side, and will take all the integers like minus 5, minus 4, minus 3, minus 2, minus 1, then 0, then 1, 2 and 3. It will stop with this 3, and that is going to be the last element of this set. I hope you are able to understand the explanation what is given. Okay, yes, fine. Okay, and yeah, coming to the 8th subdivision, again interesting question, another interesting question we have. So here the question is like the set of all integers x for which 60 by x is a natural number. Okay, so such an interesting question we have. So here we have the set, and this set what we have here is like we should have set of all integers x, again set of all integers x they are asking, but for which 60 by x is a natural number. What do you mean by that 60 by x is a natural number? So the number what I am going to take for x, and if I try to find the value of 60 divided by x, the answer what I am getting should be a natural number. This is what this expression, this definition is telling. Okay, now based on which we have to insert the elements inside this set. Okay, this is going to be our objective. So you can take any number. Okay, yes, but it should satisfy this condition. Just imagine, you just think of, can you take 0 here? Just try taking x as 0 here. Is it possible? Can you divide 60 by 0? Or you think 60 by 0 will it give you the answer to be a natural number? No, we can't assure, right? So it should be a natural number in the sense what we have to do. It should always give you a possible natural number. Okay, yes. So in that case, it should be positive also because it is natural number, right? So in that case, it should be natural number also. And from this itself, it is very easy for us to reveal that. What you can tell? We can clearly tell the value of x also what we are going to take should also be positive. Okay, we got that restriction. Okay, yes. Now, how shall we find this? Now it is very easy for us to tell the answer if you do a small trick here. Okay, let me tell how easily you can do this problem. It's going to be very easy. It's just enough if you just factorize this 60, or otherwise you try to represent this 60 in all possible products. Okay, 60, let's try to write in all possible products. Okay, in what are all the ways I can write? Let me start from 1 itself, since we are taking natural numbers for this, and the answer should be a positive number. I will take the natural numbers itself. Okay, let me start from 1. Okay, so 60 can be written as what? 1 into 60. Okay, this is one possible way. And next, go like this. Okay, 2 into 30 I can write. And next, what I can write? 3 into 20 I can write. Next, I can write 4 into 15. Or I can write 5 12s are 60. Or I can write 6 10s are 60. Or otherwise, what I will write? I will have 7 or 8 or 9. No, it is not divisible. 9 is not divisible. 10. Again, 10 means it will be like repetition. 10 into 6. That will only again appear. But it is already available here itself. So that means it is very clear that this set will contain elements, that numbers that you see here. Those numbers are what you will have inside this set. Exactly copy those same numbers and put it inside this set. That's it. Okay. So that means what numbers you will have? Let's try to arrange in ascending order. Okay. So we'll write the numbers like 1, 2, 3, 4, next 5 we have, next 6 we have, next come to that side. Okay, 10, 12, 15, 20, 30 and then 60. That's it, finished. So that means now you can check each of these elements. If you take any of these values for x, the answer what you are going to get for 60 by x will also be a natural number only. Okay, yes. So just you can try it, like 60 by 1 will be 60, that's a natural number. 60 by 2 is 30, that's also a natural number. 60 by 3 is 20, is also a natural number, and so on. Okay, even if you take 60 by 10, it will be 6, that is also a natural number. So any number you take here, it will be that 60 by x, what you are going to calculate, the answer will be a natural number only, and that is how we have defined this set. Yes, okay, I hope you are able to understand these subdivisions also. Yes, let's move on to the next subdivision. Let's complete the other subdivisions of the second question also. Yeah, here continuing with this, we have the 9th subdivision. Here the question is, set of all elements x such that x belongs to integers where the condition is minus 1 by 2 is less than x is less than 9 by 2. That is, x, this set of elements contains, this set contains like elements which are integers, and here this x is between, okay, set of all x such that x is an integer, and this x is between what two values? It should be more than minus half and less than 9 by 2. This is what is given in this question. So let's see what are all such integers we have here. Okay, yes. Now before that, it will be very comfortable if we just try to turn these two fractions to be values, okay, decimal values. Let's try to do that. If I try to do it, what I will get here is like, I will have minus 1 by 2 I can write as minus 0.5, and this 9 by 2 I can write as 4.5. So now it will be very easy for us to visualize what numbers we can have here in this set. Okay, so that means we have to clearly note down all integers of this range, more than minus 0.5 but less than 4.5. That means obviously what numbers we will have? The first integer we will have is 0 only, right? Okay, because minus 1 won't come, because minus 1 will be still lesser than this value. So we have a value which should be greater than minus 0.5, right? So that means we can have 0 we can have. Next, what numbers we can have? We can have 1, we can have 2, 3 and then 4. Up to 4 we can have, but x should be less than 4.5, right? That means up to 4 only we can have. We can't go for the next integer which is 5. Okay, so that means we can have only 0, 1, 2, 3, 4. That's all. These numbers will only come here in this subdivision 9, this question. Okay, yes. Now moving to the next subdivision, 10th one. Here we have set of all elements x such that x is a natural number and x 4x minus 3 is less than or equal to 15. Okay, we have to take only natural numbers here. So that means what numbers will come here? Natural numbers means we will have 1, 2, 3 and so on. Okay, these numbers will only come, but it should satisfy the other condition. We are given an inequality here. 4x minus 3 is less than or equal to 15. So it should satisfy this inequality. In such a way only we have to take the values for this set. Okay, I mean take the elements for this set. Okay, so that means we will try from the first number itself. Okay, shall we take x as 1? Try taking x as 1 here. So we will have 4 ones are 1. Sorry, 4 ones are 4. 4 minus 3 will be 1. Yeah, 1 is less than or equal to 15. It's correct only. That means I can very well have 1 here. Next, what number we can have? Shall we have 2 here? Try putting 2 here. So if you put 2 here, what will happen? We will have 4 2s are 8. 8 minus 3 is 5. That is also allowed. Why? Because 8 is also less than or equal to 15. So yeah, as long as it's going to satisfy, we can take all natural numbers. Okay. Next, number 3. Try 3 here. So 4 3s are 12. 12 minus 3 is 9. Yeah, of course we can have 3 also here. Next is 4. 4 4s are 16. 16 minus 3 is 13. Of course, 4 can also be put inside. Next number will be 5. So 4 5s are 20. 20 minus 3 will be 17. 17 is less than or equal to 15. Is it satisfied? No, it is not satisfied. That means we can have natural numbers only up to 4 for this question. Okay, this is going to be the answer for this question. Yeah, next one, moving on to the next question, we have set of all elements, set of all numbers x such that x is a natural number, because they are given x belongs to n, right? So x is a natural number and x square is less than 40. So this is what we are given. Okay, so that means here again we have to take only natural numbers. Natural numbers in the sense we can take from which number? We can start from 1. Yes, okay. So I will start from 1. But whether 1 will satisfy this condition? 1 square. What is 1 square? 1 square is 1. 1 is less than 40. Yeah, it is correct only. That means we can very well take 1 inside, no problem. Okay, next number is 2. Are we allowed to take 2 here? Just try it here. 2 square is 4. Is 4 less than 40? Yes, that means 2 also I can take. Go on. Okay, next I can check for 3. Okay, 3 square is 9. 9 is less than 40. Yes, true. That means 3 is allowed. Next is 4. 4 square is 16. 16 is less than 40. Yeah, 4 also we can take. Next is 5 square 25. Yeah, I can take. 6 square is 36. Yeah, 6 also I can take. What about next number 7? 7 square will be 49. But it won't obey, it won't satisfy this condition. So that means we can have only till 6. So this is going to be the answer for our this subdivision number. What about this one? 11. Sorry, this is going to be subdivision 11, right? Yeah, subdivision 11. Okay, yeah. Next is subdivision number 12 we have. So here set of all x such that x is an integer. Okay, so this set z means it is an integer. Okay, set of all elements x belongs to, that x belongs to set of integers. Okay, that means x is an integer here. Okay, so let me just specify it in a small way. Okay, yeah, yes, integer, and x square is less than 16. Okay, this is what we are asked to try here. So what about x square is less than 16? So the value of x square should be less than 16. In such a way we have to take values for x. Okay, yes, but this time we can take any integer. That integer should satisfy this condition. In that way only this question is asked, right? So that means what integer we can have? Integers means we can take negative numbers and also positive numbers. Okay, and remember one thing here the condition is x square is less than 16. Okay, just think about whether a positive number or a negative number, when you square it, what happens to the answer? The answer will always be a positive value only. Is it or not? If you take a positive number, square it, the answer will be positive. If you take a negative number and square it, still the answer will be positive only. Is it or not? Because minus into minus is plus only, right? And if you take 0, what about 0? 0 square will be 0 only. Okay, yeah, fine, yes. Now we'll have to check this condition. So from which number we can start? So you can try taking from 0 itself. Okay, so definitely 0 will be there. Okay, so since I will have negative numbers and also positive numbers, I am just starting from the middle. So 0 will be there. And what about this positive side? What numbers will be there? Like previous question, we'll try this positive numbers. Okay, can we have 1 here? Yeah, very well we can have, because 1 square is 1. 1 is less than 16, so 1 we can have. What about the next number 2? 2 square is 4. Yeah, 4 is also less than 16. 2 we can have. Next is 3 square is, what about 3 square? 3 square will be 9. So yeah, 3 also we can have, no problem. What about next number 4? 4 square will be 16, but unfortunately 16 is not less than 16. Okay, remember the condition. So we should be very careful here. Here they have not used the condition less than or equal to. Okay, if at all they have used the condition less than or equal to, 4 will also be allowed. But here what they have used the condition x square is less than 16. So less than is strictly less than. Okay, that means 9, up to 9 only we can have. So that means up to 3, x is equal to 3 we can have. But 4 we are not allowed to take, because 4 square is 16. 16 is not less than 16. That means this extreme I can have only up to 3. And what about the left extreme? I mean the negative side. Negative side also, it is very easy for us to identify, because whatever numbers we had the positive side, the same values in the negative sign also will have, because minus 1, minus 2 and minus 3, the same numbers of minus sign, negative sign will also be present. You can even check it. Minus 1 square is still 1. That will be 1 square. 1 square will be less than 16. Minus 2 square is 4. 4 is less than 16. Minus 3 square is 9. 9 is also less than 16. But if you go even before, okay, I mean like minus 4, if you go, minus 4 square will be still 16. That will not obey this condition. That means these numbers are what? These elements are what you will have in this set. Okay, yes. Yeah, quickly going to the next question. Subdivision number 13. Okay, it's 13, right? Yeah. The set of all digits in our number system. Okay, our number decimal system, what digits we are using, that set is what they are asking. It's very simple, right? So what digits do we use? we use digits right from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. So these are going to be the digits we are using, right? So that means these are all the elements of this particular set. Okay, so we need not write numbers like 10, 11, 12, because they are just asking only the digits. Okay, the 10, if you take 10, is composed of this 1 and 0 only. Okay, and so on. Okay, only the digits they are asking, so only the single digits alone, it is enough for us to represent here for this set. Okay, yes. Yeah, coming to the next one. Question number 14, subdivision number 14, we have set of all letters in the word trigonometry. Okay, another interesting question. So here we have to list, or we have to take the set of all letters in the word trigonometry. That means we have to collect all the letters in this word trigonometry, but provided very important condition. What is the condition? We should not repeat any elements inside a set. Okay, because when you define a set, the numbers, the elements what you have inside should be unique, right? You should not have a repetition. Okay, so in that case we will have to just simply write the letters here, but we have to avoid the repetition. Okay, fine. So it means we'll start from the first letter. I can start from T, next I will have R, next I can have I, next I will have G, next I can have O, next I can have N, and again after N we have got another O. Okay, no need to write this O. Okay, next is M, we have, you can write M. Next we have E is there. Okay, we can even write that E because it's not repeated. Okay, E. Next we can have T is there. Again that T is again repeating, right? So this T we should not again write it. Next we have R is also there. Okay, again that R has already appeared, that's R, we need not write it. And next we have Y. Okay, Y is not repeated, so I can write Y here. So that means these are all the elements we will have here. Okay, T, R, I, G, O, N, M, E, Y. Okay, I hope any letters, no letters repeated here, right? Okay, we can even check it. Okay, T, R, I, G, O, N, M, E, Y. Yeah, fine. That means no letter is repeating here. That means this is going to be the set of all elements we have for this question. Okay, moving to the next question. Here another interesting question. We have set of all vowels in English alphabet which precede Q. So what do you mean by that? It's again very simple to understand. We have to list all the vowel letters in the English alphabet which precede Q. What do you mean by precede Q? That means which are going to be appearing before Q. That's all. Okay, before Q. This is what is going to be the question. And what letters we have to take? We have to take letters only, vowel letters. Okay, that is the condition. So we have to just take vowels, all vowel letters which are appearing before Q. That's all. Okay, so we very well know what are the English alphabet vowels we have. We have got totally 5 vowels, right? A, E, I, O, U. Okay, so those letters are what should be coming here, but among them whichever letter comes before Q, only those vowels should be listed here. Okay, in that case we can have A, we can have E, we can have I also, we can have, next O also we can have, right? Because O comes before Q only. Yes, O also we can have, O. And then what about U? U will come after Q, is it or not? So that means we are not allowed to take U here. Why? Because Q, R, S, T, U, that is the order, right? So after Q only that U is coming. That means U is not preceded by Q. Okay, that means like these are all the set of elements you will have inside this set. Okay, yes. And we have the last question of this, last subdivision of this, question number 2. This also we'll solve it. So here we have X. X is a consonant in English alphabet which precedes K. Okay, so here again a very similar question. So precedes, means again it's like before. Okay, so we have to take the elements in such a way that X is a consonant. Okay, this time we are allowed to take, we have to take only consonant. Okay, the previous question we had vowels. Okay, but this question we are asked to take consonant letters. X is a consonant in English alphabet which precedes K. Okay, this is what we are asked to get here. So that means we have to list all the consonant letters. What do you mean by consonants? English alphabets which are except vowels is what we call it to be consonants. Okay, that means the first consonant will be what letter? B is the first consonant letter. Okay, B, C, D, then F, it follows like this. Okay, yes, these are going to be the consonant letters because we have to leave all the vowels. I mean A, E, I, O, U, these are all we have to leave it, except those letters. The other 21 letters in alphabets is what we call it to be consonants, and we have to take consonants which are preceding, I mean before K. That's it. That means I can take B is the first consonant. Next I can take C, I can take D. I can't take E. E is a vowel. Okay, E, F, I can take F, G, H, I can't take, J I can take, that's all. After J, K will come, so that means we can take only up to this J only. Okay, yes, so that means these are going to be the elements that we have in this set. Okay, yes, I hope all these questions are very clear to you, and if at all you have any doubts, you can again rewind this video and then see it here. And again, if you have doubts, as usual, you can comment in the comment box. Okay, yes, yeah, I think we have completed the second question, all subdivisions from the second question successfully. Now let's move on to the third question. Moving to the next question, question number 3 here. So here the question is, write the following sets in the builder form. This is our question. So here we can see these subdivisions. All these questions are given in terms of roster form. Is it or not? So you can see all these sets here. They are all defined in terms of roster method. Roster method is what we have already seen. Now we have to change, or we have to represent the same sets in terms of set builder form. This is going to be the question. Okay, so how can we do this in a set builder form? We have already seen an example, right? While we are solving the previous one of those questions, there we came across the set builder forms there. So set builder form is nothing but defining a set in terms of conditions. Okay, we have to build some proper valid conditions that should exactly match the elements, okay, that we have inside that set. In such a way we have to properly form. Okay, there only we should be very careful in using that set builder form. Okay, so we have to properly frame the conditions so that we are not going beyond any condition, okay, which is going to affect the elements in the set. Okay, in that way we have to properly frame the condition, and then we have to form the set builder. Okay, so this is what we have, this set builder form. And let's try doing or representing all these given sets in terms of this set builder form. Yeah, we'll try from the first subdivision. So we'll see the question here. So here we have the set of elements 1, 3, 5, 7, 9, 11 and 13. So first of all, whenever we are given any set, it is better if we try to see any pattern, or we can observe any uniformity, any alignment or any pattern we have within the elements. Okay, so now if you carefully see here, it is very obvious that we have all these odd numbers here. Is it or not? So 1, 3, 5, they are all odd numbers. Up to 13 we have got here, and that too all these numbers are going to be what? Positive. I mean, I can even tell natural numbers. Okay, so that means how we can define this set here? Let us see that now. Okay, so set of all elements X. Let's start this way. Okay, because this is how they will start any set builder form. Set of all elements X such that X is an odd natural number. I think defining this way will be very much valid, or very much appropriate, meaningful for us to define this set. Okay, X, set of all element X such that X is an odd natural number. Okay, so this looks very valid, right? Why? Because like X is an odd natural number. If I take, it will be very, very valid, because all these numbers are odd natural numbers only. But we can't leave it as it is. Okay, why? Because we don't have all odd natural numbers here in this set. We have numbers only up to 13. So that means we have to give some restriction here, right? So for which what I'm going to do is set of all odd natural numbers. X is an odd natural number less than 14. We can define it like this. I think this will be very meaningful. Is it or not? So X is an odd natural number less than 14. Less than 14 in the sense less than 14, up to 14, just before 14 we have to stop there. And of course we have only 13, up to 13 only we have in this question, right? So that means defining the set in this way will be very, very meaningful, and at the same time we are not breaking, or we are not going beyond any of these conditions that is given in the set of elements in the question. Okay, yes, fine. Yeah, I hope it is very clear to you. And is there any other way with which we can represent the same set in set builder form? Yeah, let's try doing that. Okay, so set of all elements X, let me just try giving the same set in a different way. Okay, in another set builder form, set of all elements X such that X is equal to, okay, just see it here, X is equal to 2n plus 1. I have a reason why I'm doing this. Okay, X is equal to 2n plus 1, and what we will try to do now here is where n belongs to the set of whole numbers. I think you are okay with this, right? Set of whole numbers. What do you mean by this? W means set of whole numbers. What do you mean by whole numbers? Whole numbers means it will be like 0, 1, 2, 3, 4 and so on. Okay, this is going to be a set of whole numbers. Now try taking values for n which are whole numbers. I think I can start from 0 itself. Okay, now you try putting n as 0. What you will get? You will get 2 into 0 plus 1, which will be this one. And take the next whole number. Next whole number will be 1. Put 1 here. You will get 2 into 1 plus 1, which will be 3. Next number 2 into 2 plus 1, which will be 5. Okay, and so on. It will be following like this. So that means I can very well frame this condition also, but we have a restriction. Okay, we have restriction because we have elements only up to 13 here. So that means we can restrict some condition. We can put some condition for this n. Okay, and what value we can put for n? We can take n up to maximum. What value we can take? Up to, we can take it up to I think 6, up to 6 we can take it, right? Yeah, we can take up to 6. So that means n is less than or equal to 6. Why? Because if you take up to 6, you can just take it. Okay, so 2 into 6 plus 1, which will be 13. That's it. Okay, just a minute, I've just left my cap here. Yeah, okay, yes, thank you. Okay, yes, x is equal to 2n plus 1, up to 6 we can take it. Okay, so it is like, yeah, 2, 6, 12, 12 plus 1 is 13. Yes, we can't go beyond this 6. Okay, why? Because if I take n as 7 means you will not be able to take, because you will be exceeding the number that we have in the set. That's why. Okay, so defining our set in this way also will be very, very meaningful. Okay, yes, I hope you're able to understand this. Yeah, yes. Next, coming to the next one. So here we have another set. Okay, so here our set is like a set of all elements. We have like a 2, 4, 6, 8 and so on. So this is what we have in this second subdivision. So how can we define this set of all x such that, can you just carefully see what numbers we have here? We have all even numbers. Okay, so that means x is an even natural number. Even natural number, we can define this way. But at the same time, do we have any restrictions here? No, we don't have any restrictions because the elements are going and going and going. Okay, so that means there's no restriction at all here. So we can have any natural number unless it is going to be not a negative value. Okay, so all of them are going to be positive only. So when I include that natural itself will take all positive even numbers. Okay, so that means x is an even natural number. Set of all elements x such that x is an even natural number. We can define it in this way. Okay, this will be very apt. Or otherwise I can even define the same one like x such that x is equal to 2n. I can put 2n now, right? Okay, now I can put 2n where n belongs to n natural numbers. I can define like this, right? Why? Because n belongs to n means n is going to be any natural number. Okay, so can I take the natural numbers? Natural numbers will start from 1, right? Now you can take values for n to be all natural numbers. Let me start from 1 because natural numbers means it will start from 1 only, right? So 2 1s are will be this 2. Now next one, 2 2s are will be 4, 2 3s are will be 6, 2 4s are will be 8 and so on. It will be accomplishing all the numbers that you have in this set. Okay, I can even define this way, right? Okay, so it won't break any of this condition. So I can take this way and also there's no restriction at all. So we can close our braces here itself. Okay, so defining this way will even be apt to define this set. Okay, what we have here. Yeah, coming to the next one. Next, another question is what we have here. We have set of numbers. We have 3, 6, 9, 12 and 15. This is what we have. So how can we define this set of all elements x such that, can you just see what numbers we have here? We have the numbers which are all multiples of 3. Is it or not? Multiples of 3. So we can have all multiples of 3. So how can we define this? X is a natural multiple of 3. We can have it like that. Okay, multiple of 3, we can have it like this, multiple of 3. So natural number which is a multiple of 3, that is what it would mean. So x is a natural multiple of 3, natural number which is a multiple of 3, but we can't have any natural number here. Why? Because we have the restriction only up to 15 here. Is it or not? So that means what I can do here is I can give a restriction here which is less than or equal to 15. Okay, less than or equal to 15. We can define it like this. Okay, so maybe defining like this will be very apt for you. Maybe you can again read again and see. X is a natural multiple of 3 which is less than or equal to 15. If I include less than or equal to 15 itself, it will take up to 15. That's the reason I am defining like this. Okay, or any other ways we can represent this using this kind of variables. Yeah, we can still do that. X set of all elements x such that x is equal to 3n. I can define like this, right? X is equal to 3n where n belongs to n And also we have restriction up to what number? Only we have 5 numbers. Okay, so that means I can take n is less than or equal to 5. We can define like this. Can I check it and see? N belongs to n, that is n is going to be a natural number less than or equal to 5. That means I can take this n value to be 1, 2, 3, 4, 5. Now you take x is equal to 3n. What happens? 3 1s will be 3, 3 2s will be 6, up to 3 5s I can take. 3 5s will be 15. This will also be very apt in defining this set. Is it or not? I hope you are able to understand all these things. And yeah, here we have another question here. So coming to the fourth subdivision, here we have the set of elements. The numbers we have here are 2, 4, 8, 16, 32, 64. So let's try to observe any pattern here. Like here we got patterns, right? So odd numbers, even numbers, multiples of 3, like that. Here also we'll try to define or observe whether we are able to get any pattern here. Okay, so when you try to do that, what happens is like all these are going to be even numbers. And further, what else we can tell? We'll just try doing powers calculation. Shall we do it here? So this 2 will be nothing but 2 power 1. Is it or not? And next, this one, this 4 is 2 square. This 8 is 2 cube. This 16 is 2 power 4. So that means it is very clear that all these numbers are going to be powers of 2. That's it. Very simple, right? So every number you see here in this set are going to be 2 power 2 power 2 power. In that way only you have. So that means let's use the same definition itself here to form the set builder. Okay. So set of all elements x such that x is equal to 2 power n. We'll have it like this. X is equal to 2 power n we'll have. And at the same time, what about this n? N also we have to define, right? Once we use the notation in terms of n, we have to define what is n. Where n is a natural number. Why? Because we have n starting from 1, right? Is it not? Yes or not? 1, 2, 3, 4 is going like this. N is belonging to this natural number, set of natural numbers. And up to what number it is going? Up to what number? We can have 2 power 5 is 32. We will have 2 power 6 is 64. That means n is less than or equal to 6, up to which we can have. Yes, okay. I hope it is very clear to you. Set of all elements x such that x is equal to 2 power n, where n belongs to the set of natural numbers and n is less than or equal to 6. Okay, this is going to be the condition. Okay, I think it is clear to you. So let me read it again and show you. N belongs to n and n is less than or equal to 6. So that means it will include numbers, natural numbers up to 6. Okay, since I am including less than or equal to, it will include that 6 also. Okay, yes. So this is how we can define this set. And yeah, now coming to this fifth subdivision, here we got the elements 5, 25, 125, 625. Let's try doing the similar calculation. Okay, let's try applying the similar method here also. So once we try to do is, what we'll get is like here we'll have this 5 as 5 power 1. This 25 is 5 power 2, this 125 is 5 power 3, this 625 is 5 power 4. So here we got all these values to be the powers of 5. So that means what we can do here is like we will have set of all elements x such that x is equal to 5 power n. So because here all the elements are in terms of 5 power something, right? So 5 power n, and n belongs to natural numbers. And here what about the restriction of n? N can take up to what values? N can take up to the values up to 4. So that means n is less than or equal to 4. We can have up to this one. So that means this is going to be the proper way to define this set. Okay, yes, I hope it is very clear to you. Yeah, continue. We'll do the other subdivisions also. We got other 3 subdivisions also from this question number 3. So we'll complete those questions also. Next is subdivision number 6 of question number 3. So here we have the set 1, 4, 9, 16 and so on up to 100. So let's again try to observe whether these numbers are following any particular pattern. So if you carefully see here, it won't be much complicated for us to observe that they are nothing but they are going to be square numbers. Yes. So this 1 is going to be like 1 square. This is 4 is 2 square. This 9 is 3 square and so on. So we have got all square numbers here in this set. Okay. So that means how we can define it? So here we can define this set as set of all x such that x is equal to, we have to represent that square, right? So what I'm going to do is x is equal to n square. I'll put like n square. Okay. So now what about this n? N, very simple. N is going to take what numbers? 1, 2, 3, 4. These numbers only n is going to take. So that means n is going to be a natural number. And what about the restriction? Up to what number n is taking? So we have to, for that we have to see the last number. Last number is 100, right? So it's going to be 10 square. So that means n is less than or equal to 10. That's it, finished. I think it will be very meaningful for you to understand, right? So x is equal to x, I mean the set is containing all elements x such that x is equal to n square, where n is a natural number less than or equal to 10. Finished. That means n can take what value? N can take numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up to 10 it can take, and x will be what? That n square, that's what is going to be this x. So that is how this set is defined. Okay, yes. So I think it is clear to you. Now, yeah, coming to the next one, 7th subdivision. Here we have the numbers 1, 4, 9, 16, 25 and so on. Yes, it's very clear and obvious that here again we have the same square numbers repeated, right? 1 square, 2 square, 3 square, we have the same numbers. So I can define this set also the same way how we try to define the previous one. So we'll have set of all elements x such that x is equal to n square. And what about n? N here also it is going to take natural numbers only, right? So n belongs to a set of natural numbers. But what about the restriction here? Here do we have any restriction? I mean, like, do we have any ending elements here? No, this set is going and going and going. Okay, yes. So that means here we don't have any restriction. So that means n is allowed to take any natural number, right? Okay, because we don't have any maximum limit and all, right? So that means n can take any natural number. So we can define this set simply like this itself. Okay, x set of all elements x such that x is equal to n square, where n is any natural number. That's it. Okay, here we got a restriction only up to 100. That's the reason we took n up to 10. But here we don't have any such condition, right? So that means we can take n to be any natural number, right? Okay, this is how we have for this one. And yeah, this is how we got the answer for this question. Yeah, coming to the last subdivision of this third question. So subdivision number 8. So here what elements we have, what numbers we have in this set? Let us see that. So this set contains numbers like 1 by 2, 2 by 3, 3 by 4, 4 by 5 and 4 by 5 and so on. Okay, this is all we have. So that means very clearly we got all fractions only in this set. Is it or not? Only fractions we have here. And that too, let's see whether we are able to form any pattern for this fraction. Okay, so that means you take the first one, we have 1 by 2. Next one we have second one 2 by 3. Next one we have 3 by 4, 4 by 5. It is going like this. Is it or not? So that means here what happens is, like, here we have all the natural numbers and the denominator part is going to be the next number, the next natural number. So if I want to present it like this in a very precise way, how I can present the same set is, I can just rewrite it as 1 by, this 2 I will write as 1 plus 1. Next this 2 by 2 plus 1. Next this one 3 by 3 plus 1. Next 4 by 4 plus 1. Right? I can write it like this. So this way I can very well define this set what we have here. Is it or not? So now this will be very easy for us to present the format in a set builder form. Just listen what I'm going to do here. So that means now I can define x as x is set of all elements x such that x is equal to, now just use the same pattern to define this, x is equal to n by n plus 1. I hope it is very clear to you. X is equal to n by n plus 1, where what about this n? N will take what values? N will take all natural numbers. Yes. Now we can try testing all the natural numbers. Natural numbers means it will always start from 1, right? So we can take from 1. So 1 by 1 plus 1, which is what is the first number. Next n can take 2, 2 by 2 plus 1, n can take 3, 3 by 3 plus 1. This is what we have here. Is it or not? So it means we can take any natural numbers for n. And do we have any restriction here? Here again we don't have any restriction like we have for the previous question. We don't have any restriction here. So it means defining the set like this will be very apt. So we can define like this. Yes, okay? Yeah, fine. Okay. Now I hope you are very clear with all the subdivisions we tried from this third question. All the problems are very clear to you. Next we'll move on to the fourth question. Next we have question number 4 with us. Here our question is, find the cardinal number of the following sets. So first of all, we should be very clear about what do you mean by the cardinal number of a set. Okay, the idea is going to be very simple. So cardinal number of a set, that means, it simply means how many elements are there in that set. So it represents the number of elements in that set, and at the same time we should be very clear about how many unique elements are there. Okay, so being said, we don't have any repeated things, so we'll have to consider only how many unique elements are there in that set. So this is what is the meaning of this cardinal number. Okay, all right. So let's be sure about that definition first. So cardinal number, what do you mean by cardinal number of a set? Cardinal number means number of elements you have inside a set. Okay, so this is what you mean the cardinal number. Okay, now with this idea, let's try to get the answers for these following questions. Okay, so this is all about this question number 4, and we have got totally 5 subdivisions here, just 5 subdivisions. Let's quickly try to work out the questions. Okay, yes. So yeah, first subdivision, here we have a set where inside that set there is nothing available. Correct? Yes. So there is a set here, so we can clearly see the braces here, so that means it's a set. And if you see inside, what is there inside that set? There's nothing inside. So there's nothing available inside this set. This set is what you call it to be an empty set, or otherwise we call this as a null set. Okay, yes. So that means how many elements are there here? It is very clear, right? So here the number of element is going to be 0. So here this first one, it contains only 0 elements. So that means the cardinal number of this set is going to be 0. That's it. That is going to be the answer. Okay, all right. Yeah, now come to the second subdivision here. Here again we got a set. Okay, yes. So in this set, can you see elements inside? Yes, of course we can clearly see an element which is present inside. We have a number which is 0. Is it or not? Yes. So that means there is 1 0 present inside. No matter what element is there, but we must see whether there is element or not. Yes, it is available. And see how many elements are there? There is 1 element available. So that means the cardinal number of this set is going to be what? It is no doubt, it is 1. Alright, yes, I think you are able to understand this. So just because you see the number 0 inside this set, don't put the answer as 0. Okay, that will be surely wrong. It's a great mistake. Okay, so when it will be 0, when the cardinal number will be 0, when your set is empty only, the cardinal number of that set is going to be 0. Why? Because there's no elements at all. That's why we can come to a conclusion that the cardinal number is 0. But here if you see this set, though it is containing 0, it doesn't mean that it is not containing any element. It is containing an element 0. Correct? In that way, there is 1 element, so that means cardinal number of this set is going to be 1. That is going to be the answer. Yeah, now come to the third subdivision. Here we have a set A, and let's see what is there present inside that set A. Okay, so set A contains the elements 1, 2, 2, 1, 3. So these are going to be the elements. So that means the cardinal number of this set is going to be, don't quickly count and then get the answer. Okay, so 1, 2, 3, 4, 5, there are 5 elements. We should not quickly arrive to such a condition, okay, such a conclusion. Okay, that will be absolutely wrong. So instead, what we have to carefully see here, we'll have to see whether the elements are repeated. Why? Because we have already seen, right, cardinal number stands for what? Basically a set itself means what? A set means that should contain unique elements without repetitions, right? Okay, so in that way, if you want to try to write this set, so how can we rewrite this set basically? So this can be rewritten as just 1, 2 and 3. This is what is this set, is it or not? No doubt, right? Why? Because like we have 1 is there, we have 2 is there, and we have 3, and others are repeated. Correct? This 2 is repeated, this 1 is repeated. So that means the correct proper way to define this set is going to be like this way only we have to define. Now we can easily get what is the cardinal number of this set. No doubt it's going to be 3, because there are 3 elements inside that set. Is it or not? So that's it. Okay, fine. Yeah, coming to the fourth subdivision, here we have the set of all letters in the word principal. So this is going to be the question. Okay, set of all letters in the word principal. So first of all, let's frame this set first, then we can go find the cardinal number. Okay, so first of all, let us see set of all letters of the word principal. Okay, shall we frame the set? So that means our set should contain what kind of elements? It should contain the letters of this word. Okay, yeah, we'll go for that. So first we have principal, we have P is there. Yeah, okay. Next R is there. Okay, then I is there. Then N is there. Then C is there. And once again, if you see I is repeating, right? So don't repeat the elements. Again, come to this P. P is again, it will be repetition. So don't repeat it. Next we have A. A is not repeating. Okay, we can take A. Very well, we can take. Next we have L. L is also, this is the first time it is coming. L is also not repeating. So L. So that means these are going to be the elements of this set. Okay, the set of all letters in the word principal, the set is going to be this set only. I think now you can very easily get the cardinal number of this set. So now count and see how many elements are there. 1, 2, 3, 4, 5, 6, 7. That means cardinal number of this set is going to be, the answer is 7. 7 is the answer. Okay, yes, fine. Yeah, last one, the set of all vowels in the word principal. So now this time we are asked to find the set of all vowels in the word principal. Okay, so this time the same word is given like we have in the fourth question. The same word is given here for the fifth question also, but this time what we are asked to get here is the set of all vowels we are asked. The previous question set of all letters they asked, but this time this subdivision fifth one we are asked to get set of all vowels alone. The vowels alone we are asked to take. Okay, so in that case we can just pick the vowels alone. Okay, I think it is better if we compare from this set itself, the previous one itself. Okay, why? Because we have already framed the set, right? Just pick only the vowel letters alone. Vowel letters alone. Okay, so if we go for vowel letters, we will end up with only this I and then any other, this A. That's it, no other vowels, right? Because P, R, N, C, L, they are not vowels. Okay, so I and A are the only two vowels present here. So that means set of all vowels in the word principal is going to be I and A. That means cardinal number is, how many elements are there? It's clear, right? 2 elements. So that is going to be 2. Cardinal number of this one is going to be 2. And yes, these are going to be the answers for our fourth question. For all the subdivisions of fourth question, let's move on to the fifth question. Next we have question number 5 here. So find the cardinal number of the following sets. Again, this question is again based on finding the cardinal number of the given sets. And here we have got 3 subdivisions here. Let's quickly try to work out these questions one by one. Take the first subdivision. We have set A. They are defined in the form of set builder form. Okay, yes. So it is very clear that is given in terms of set builder form. And let's see here. Set A is given by set of all elements x such that x is a 2-digit number. So that is, this set is going to contain all 2-digit numbers where the sum of the digits is going to be 8. So this is the way they have defined this set A. Okay, so that means based on these conditions, let's try to find what are all the elements we will have inside that set A. Okay, all right. So remember, it contains all 2-digit numbers and sum of the digits should be 8. Okay, yes. So let us think about what can be such a first 2-digit number. Okay, so 2-digit number itself we can start from 10 only, because 10 is going to be the least 2-digit number. But if you take the number 10, okay, what happens to the sum of the digits? If I take the number 10, the sum of the digits will be 1 plus 0, because 10, how we will write 10? 10 we will write as 1, 0, correct? So that means the digits is going to be, digits are going to be 1 and 0. You have to add the 2 digits. So this is what they are coming to say. Okay. So in that case, if I add 1 plus 0, I will get only 1. But what we need here, we want the sum of the digits to be 8. This is what our condition is given here. Okay. So in the case, what number we can have? So if I take the first place as 1, now you can easily visualize until the second place I can put 7, is it or not? So I can take the number 17, correct? Yes. So 1, 7. Now you add the 2 digits, what number we'll get, what answer we'll get? We'll get the answer as 8, right? So this is what they're coming to say. So the first element itself will be 17. I hope you are able to understand now, because 2-digit number we have to take and sum of the digits should be 8. So 1 plus 7 is 8 only, correct? Okay. Next, what will be the next 2-digit number? So after 17, what will be the next number? We can go for 2. Okay. So I'll take the first digit as 2. Next, what will happen to the second digit? Second digit will become 6, because 2 plus 6 only will give you 8, right? Is it or not? So that means 26 is going to be the second number. Okay. Now we'll have a clear pattern. We can now easily get the other numbers also. Let's just see what we have to do further. Okay. Next number will be, we'll take 3, and if I take the first digit as 3, the second digit is going to be 5. So that means my third number is going to be 35. And what can be the next number? Next number will be 44, because 4 plus 4 will only give you 8. Okay. Next number after 40s, we can go for 50s. Okay. So 53 I can take, because 5 plus 3 will be 8. Next I can take 62 I can take, because 6 plus 2 will be 8. Next I can take 71, because 7 plus 1 is 8. And next last one more number is there. What number we can take? We can take 80, 80, is it or not? Because 80 is also a 2-digit number only, right? And also 8 plus 0 will give you 8 only, right? Okay. And at this situation, you will have a doubt. Why can't we take 08? Why can't we take 08? Yeah, of course we can take 08, but 08 is basically a single digit number, is it or not? Why? Because 08 simply means 8. So that means that 8 is going to be a single digit, 1-digit number, which we are not allowed to take as per this question's condition. So that is the reason we are taking numbers which are more than 10, okay, which are more than 10, okay, 10 or more than 10, okay. So in that case, first number itself will be 17 and the list is going and going, and the last number we are ending with 80, that is 80, okay. So that means the set which is going to satisfy this condition is going to be this set only, and we are asked to find the cardinal number of this set only. I think now we can very easily count and then tell how many elements are here. 1, 2, 3, 4, 5, 6, 7, 8. That's it. That means the cardinal number of this set is going to be, the cardinal number is going to be 8 is the answer. Okay, yes, fine. I hope you're able to understand this. Now come to the second question. Second subdivision, here we have set of all integers x for which 30 by x is a natural number. Okay, if you remember, just some time before we tried a similar kind of question here. So set of all integers x such that for which 30 by x is a natural number. So that means immediately what we can try to do. So 30 by x, what numbers I have to take for x? This set will contain what elements? It will contain all elements x. In what way we have to take x? In such a way that 30 by that x value, if I divide, I should get the answer to be a natural number. Okay, yes. The same way, sometime before we just tried for another number. We got a question based on 60 by x, if you remember. Okay, you can even rewind this video and then see. We can find that question. 60 by x is a natural number. That way we got a question previously. And this time we are getting 30 by x is a natural number for the numbers we are going to choose for x. Okay. And what we can do here? Again, like how we tried there, the same way we can try here. That is, I am going to take the 30, I am going to factorize it in pairs. Okay, so how I can do that? I can just do it like 30. I can do it like 1 into 30. I can write 30 as 1 into 30. Next, what I can write? 2 into 15 I can write. Next, what I can write? I can write 3 into 10. I can write 3 tens are is 30. Next, I can write 4 into, no, not possible. 4 into is not possible, right? Because 4 into, if I try to do, I can't divide 30 by 4. That is not possible. Next, I can go for 5 tables. 5 into 6 I can do, right? 5, 6 are 30 I can do. That is possible. What about next? Next, if I go, I will get 6, again 5. 6 5s are only I will get. That is like repeating the same numbers, okay? So that means the unique numbers, if you see, these are going to be the unique numbers, okay? So that means this set will contain what elements? Just write the numbers in a proper order. 1, 2, 3, 5, 6, 10, 15 and 30. That's it. 30. Okay, these are going to be the numbers. That's it. Okay, very simple to understand. Now you take any of these numbers, numbers you can take as x, and you try to divide 30 by x. Always the answer what you are going to get will be only natural numbers. Okay, and why are we not going for any negative numbers? Like if you take negative numbers when you divide, the answer will also become negative. But we are given in the question to be natural numbers. Okay, that point we should forget, never forget. Okay, so always carefully remember all the things, carefully see all the things that are given in the question. Okay, each and every word, every condition you see in the question is going to be important. Okay, yeah, fine. So that means these are all the possible elements you will have inside this set. So that means cardinal number of this set is going to be what? The cardinal number is going to be, I think now you can count and then tell the answer. 1, 2, 3, 4, 5, 6, 7, 8. That's it. So again, the answer is going to be 8 for this second subdivision. Yeah, okay. Next, third question. Coming to the third subdivision, here we have set of all, set is x and x contains set of all elements x such that x is a letter in the word Chandigarh. Okay, so we are given the word Chandigarh, and this set is going to be the set of all letters of this word Chandigarh. This is going to be the set. It's not much complicated for us to understand. So that means set x will have what elements? We'll have to just pick the unique letters here and put it here. That's it. That's it. Okay, fine. So we can do it very easily. So C will come. Next H will come. I can take A. I can take N. I can take D. I can take I. So far no letters are repeating, right? Yeah, I can even take the next letter. G is also not repeating. Yes. And next letter is A. A is already repeating, right? Because A already we have placed it. So again, please don't repeat A. Okay, A we can leave it. I think we can even leave R, right? I'm sorry, R is not repeating. R we have to place it. Yes, R we have to place it. And H is repeating. Yes, the last letter H is already repeating here. So again, don't place that H here. Okay. So that means these are going to be the letters. Okay, finished. That's it. This is going to be the list, and this is going to be the set of all letters of the word Chandigarh. Okay. Yeah, so that means this set is over. We have framed it, and now we have to find the cardinal number of this set. So what about the cardinal number? Again, you can count it and see 4 plus 4. There are totally 8 elements here. So again, for this question also, the answer is going to be 8 only. Yes, okay. I hope you are clear with this question also. Yeah, let's move on to the next question. Next, we have question number 6. Here is something interesting we have here. Let's see what is given to us. State which of the following statements are true and which are false. So that is, there are some statements here. We have to verify whether the given statements are true or false. This is going to be the task we have to do here, and justify your answer. So we'll have to give the explanation also. This is what we are expected to do here in this question. Okay, yes. And under this question, we have got 4 subdivisions, and what are we expected to do here is, they have given the questions in such a way that they are giving some element and they are framing the statement like whether that element is going to belong to some particular set or it does not belong to some particular set. Okay, this is how we have all these given statements here, and all we need to do it here is we need to verify whether that given element is belonging to that set or not belonging to that set. This is going to be the task. And how can we verify that? It is going to be very simple, because for each of the subdivisions we see here, and we can see each of the subdivisions we have some set which is defined. Okay, and whether the given element is going to satisfy the condition that is given in the set or not, this is what is going to decide whether the given element is belonging to that set or not. So if it is going to satisfy the given condition, then that element will be belonging to that set. But if the element is not going to satisfy, then definitely the element is not going to belong to that set. Okay, so we are going to check the condition which is given in the statements, which is given in the sets, and through which we are going to verify. Okay, yes, this is going to be the explanation I am giving orally, but let us now see how are we going to approach in solving the problems. Okay, all right, yes. And overall, finally, what we have to decide is like whether the given statement is true or false. Ultimately, that is what we are expected to do. Okay, all right. Yeah, fine. Now come to the statements. Okay, come to the first subdivision here, first statement here. We have the number 37 does not belongs to the set. How is the set defined? Set of all x such that x has exactly 2 positive factors. Okay, yes, this is what we have to test here. That is whether this 37 belongs to or not. This is the question is like that, and it says 37 does not belong to the given set. Okay, which set? Set of all x where x has exactly 2 distinct factors. Okay, 2 positive factors. This is how it is defined. Okay, now let us check whether this 37 is satisfying this condition or not. That is what we have to test it. Okay, yes. So when we try to test it, that is test whether this 37 is having exactly 2 positive factors. Shall we check it? Can you just check how many factors are there for the number 37? So what are the factors of 37? Now if you carefully, properly analyze, observe, this 37 is nothing but a prime number, is it or not? So in that case, 37, there are only 2 factors. One is this 37 and the other one is 37. So this 37 has got only 2 factors, 1 and 37, that's it. So that means 37 will definitely belong to this group. Are you able to understand what I am coming to say? 37 definitely belongs to this set. Why? Because 37 has got exactly 2 positive factors. That's the reason. Okay. So in that case, 37 belongs to this set. But what is given here in the statement? The statement says 37 does not belongs to. Right? Yes. So 37 belongs to is what is correct. But here it is stated 37 does not belongs to. In that case, answer to this question is going to be false. This is not true. This is false. False is the answer. And why? The reason is what? We need to justify also, right? That's the thing we have justified here. Why? Because 37 is having 2 factors. In that case, 37 belongs to this set, but here it states 37 does not belongs to. So in that case, we have to conclude that the given statement is false. Okay, yes. I hope now you got the idea about how to answer the given statement, whether it is true or false, how to answer it. You are able to understand with this. Now with this same idea, okay, with this same idea, we have got different subdivisions here, the other 3 subdivisions here. Here again, we have to do the same thing. We have to verify whether the given element is going to satisfy the condition that is framed in that particular questions, okay, in that particular set what is defined there. That is how we have to verify whether it belongs to or not belongs to. Let's quickly try to do it. Okay, coming to the second subdivision here, it says 35, the number 35 belongs to, okay, yes, this is belongs to, right? Here this is does not belongs to, okay, because they have striken, they gave a strike here, but here it is not like that. 35 belongs to the set of all elements x such that x has exactly 4 positive factors. Shall we check it? Whether this 35 has got 4 positive factors or not. Shall we check it? Yes, I am going to write the number 35 and I am going to check what are the factors we have for 35 or how many factors we have for the number 35. Okay, so how can you factorize the 35? I can write this 35 as 1 into 35. This is default. And what other way I can write? Can I write it in 2 tables? No, it's not possible. 3 tables, not possible. 4 tables also not possible. 5 tables I can go, right? 5 7s are 35. This is also another way I can write. Next, 6, not possible. 7, yeah, 7 is like again writing 7 5s are. It is like repeating, avoid it. Okay, so that's it. No other numbers are there. Why? Because 1, 5, 7, 35. That's all. Only these 4 numbers we have for the factors of 35. So that means 35 definitely belongs to this particular set, and also our statement also states the same thing. 35 belongs to this set, which is absolutely true. True is the answer. I hope you are able to understand this, and you are able to, I hope you are able to understand the difference how we answered the first one as false and second one as true. That also I hope you are able to understand it. Okay, why? Because here the first one, this 37 is belonging to this set, but it states 37 does not belong to. That's the reason we came to a conclusion that false is the answer. But here 35 belongs to this set and it is stated the same way in the question also. That's why we are arriving, or we are concluding the answer as true here. Okay, all right. Yeah, coming to the third subdivision here, we have the number 496 belongs to the set of all elements y. Be careful here. The set of all elements y such that the sum of all positive factors of y is equal to 2y. This is the condition given here. This is a set which is framed here in this third subdivision. Understand the statement very carefully. 496 belongs to some set. Which set it is? This set which contains what kind of elements? It contains elements in such a way that if you take the positive factors of that element and if you take the sum of, or if you add all the positive factors, the answer what you are going to get should be equal to 2y, or otherwise twice of that number. This is what they are asking. Okay, all right. So now we are going to check whether it is going to valid for our number 496 or not. Okay, yes. So that means what we have to do? We have to take our number 496, we have to take its factors and we have to add all its factors. This is what we have to do. Okay, yes. So for this, let me reveal some interesting technique for you to find the sum of all factors of a number. Okay, ready? Yes. Shall we try doing that? Yeah, let me show that separately. Okay, yes. So I am going to find the sum of all factors of 496 and I am going to check whether the answer what I am going to get is going to be equal to 2 times of this 496 or not. This is what I am going to check now. Okay, yes. If it is going to equal to 2 times of 496, then belongs to. But if it is not equal to, then this elements does not belongs to. Okay, yes, fine. Yeah, okay, yes. Now we'll come back to the condition 496. Okay, I'm going to try to find out all the factors. I'm going to find the sum of all factors of this number 496. Okay, let me just show you how easily we can do that. Okay, for that, what we have to first of all do is we have to first of all prime factorize our number. Okay, I'll show you how to prime factorize our number. Our number is 496, right? So we have to prime factorize it. That is, we have to factorize this given number with all prime numbers only. This is called prime factorization. Let me show how to do that. Okay, so I can start from 2 tables, right? Because 2 is the smallest prime number with which we can start, and also our number is divisible by 2, so we can go with 2 tables itself. So 2 tables, it will be how many times it is? So it will be 24s are 48 and balance 1 it will be 8. So 248. Again I can go for 2 tables itself. 2 tables it will be 124. Again by 2 tables it will be 62. Again by 2 tables it will be 31. But further we can't proceed. Why? Because we are ending up with 31, which is going to be a prime number, right? So in that case, this 496 can be written as what? 496 I can write it as, just see the numbers here. We have the numbers 2, 2, 2, 2. That is, we have 2 to the power 4 we have, 2 power 4 we have, multiplied by and 31 power 1. This is what we have, correct? Yes. This is what we have. So this is going to be the way how we have written now is what you call it to be the prime factorization. Okay, all right. So that means 496 is prime factorized as 2 power 4 into 31 power 1. That is okay, done. Now what next we have to do? We have to get what? We actually want what? We want the sum of all factors. This is what we want. We don't want this one, but we want the sum of all factors. So how can you find it? This is how now is what I'm going to just show you some interesting technique how we can find the sum of all factors through this step. Okay, yes. So sum of all factors is going to be equal to, so sum of all factors is going to be equal to, just carefully listen to what I'm doing now. Okay, now see here, we have prime factorized our number, right? We got what? We got 2 power 4 multiplied by 31 power 1. This is what we got, right? So in that case, what we have to do is, now take this 2 power 4. Now we have to take all possible factors we have inside that 2 power 4. That means what we have to do? We have to start from 2 power 0 plus 2 power 1 plus 2 power 2 plus 2 power 3 up to 2 power 4. Up to this we have to add everything. Yes, okay. Next what you have to do? Next come to this 31 power 1. Inside the 31 power 1, we have to take all possible factors. Now if I take that, what we'll have? We will just have 31 power 0 plus 31 power 1. That's it, finished. Okay, now this will represent the sum of all factors of our number 496. Okay, all right. Yes, I hope you are able to understand what I am telling here. So I got 2 power 4 into 31 power 1. So in that case, what I am doing is 2 power 4. I am writing all the powers right from 2 power 0 to 2 power 4. I am adding everything. This entire thing multiplied with 31 power 1 only I am having, right? So 31 power 0 plus 31 power 1. We can stop there. Okay, yes? Yeah, okay. Now when you simplify this, you will be able to get the sum of all factors of this number 496. Okay, shall we try simplifying this value? Yes, shall we do that? Yes. I don't think it will be very much complicated for us to do the problem. So anyways, we have only a small space there, right? Okay, okay. Yeah, anyways, we'll manage to do that. So first of all, what about 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4? Can you add everything? These are not going to be very big numbers. I think you will get the answer as 1 plus 2 plus 4 plus 8 plus 16. This will give you how much? This will be giving you, I think, 31, if I hope, right? 31, it will be 31. 31 into, here come to this one. This will give you how much? This is 31 power 0 plus 31 power 1. That is 1 plus 31. This will give you into 32. So overall you will be getting the answer as 31 into 32. This is what you will be getting. All right, okay. So that means now we can just get the product of that numbers. 31 into 32. How much it will be? It will be equal to, so you will have 2 here. 2 ones are 2. And next we will have 6 plus 3, which will be a 9. And then we'll have 3 3s are another 9. So 992 will be the answer. So that means sum of all factors of our number 496 is going to be 992 is the answer. That's it. We got our answer, right? Okay. So we got 992 to be the answer. But now we need to check what? Whether this is equal to twice of our number. That is 2 times of our number. Just check it. Just try to do 2 into 496. No wonder it is exactly equal to this 992 only. Okay, so that means this is equal to 2 times of our original number 496. So that means what we can finally conclude here is sum of all factors of this 496 is equal to 2 times of 496. So that means no doubt definitely this 496 belongs to this particular set. Okay, yes, all right. So in that case, what will be the answer? Whether you will answer this question as true or false. No doubt you have to answer it as true only. Okay, so since we have space is consumed here, let me write the answer here. True is the answer. Okay, yeah, fine. And for comfortability, I'll write the answers here also for all the other questions also. The first one is false, the second one is true, the third one is true, and we have got one more, last one. Yes, okay. I will move on to this question also, but before that, yeah, make sure whether you're able to understand this, okay, and also make sure whether you're able to understand this particular step where we happen to calculate the sum of all factors of a given number. What we tried here, first of all, we just started doing the prime factorization, we collected it, and from there we tried to get the sum of all factors of our number. That's what we did here, and this is what is giving us the answer. Yeah, fine. And finally, this belongs to this set, so answer is true for this question. Yeah, coming to the last subdivision number 4. Here we have the element 3 does not belongs to this set. What set it is? Set of all x such that x power 4 minus 5x cube plus 2x square minus 112x plus 6 is equal to 0. This is going to be the last question. It's very simple for us to conclude whether this 3 belongs to this set or not. That is what we have to check. Set of all x such that this given equation satisfies. This is all the condition, right? Okay. Now try putting 3 in the place of x. Just in the place of x, you just replace x as 3, or you substitute x as 3 here and check whether this statement is, this equation is getting satisfied or not. Okay, shall we check it? So if I try to do it, I will be getting 3 in the place of this x everywhere. Wherever x comes, if I try to put it, what I will get is like 3 power 4, 81 minus 5 into 3 cube. 3 cube is 27, right? So 5 into 27 will be 135 plus, next I will have 2 into 3 square, so which will be 18, minus 112 into 3, which will be 336, plus 6 is equal to 0. So this is what this statement comes to say. Do you think this will be valid? This will hold? Just see here, you need not even simplify and then get the answer, verify the answer, right? Okay, just see, the negative numbers are very huge, whereas the positive numbers are much lesser compared to the negative numbers. In that way, we can very easily, by looking itself, we can easily confirm that this answer will not simplify to 0. So in that case, this statement is not verified. That means what you can tell? That means we can clearly tell 3 is not satisfying this equation or this statement, or 3 does not belongs to this set. Okay, that is 3 will not belong to this set. If 3 is belonging to this set, definitely it should satisfy this, right? But what happened? We tried to test it. What we concluded, what we happen to see here, the conclusion was 3 is not satisfying this. That means 3 will not belong to this set. Okay, that is the conclusion we have to give here. So 3 is not belonging to this set, which is true, because like they themselves gave in the question, 3 does not belongs to this set. That means obviously this statement is also true. Okay, yes, I hope you are able to understand all the subdivisions how we tried here. Be careful in analyzing. Okay, so conclude whether the given statement, I mean like the statement is true or false. How we have to conclude it? Whether, see the question carefully. Okay, whether it is stating belongs to or not, that we have to carefully see, and at the same time check whether the element is satisfying the condition that is posted in the question. That is also important. Okay, that will only decide whether it is belonging to the set or not belongs to that set. Okay, and by which you have to take the answer, conclude the answer whether it is true or false. Okay, yes. So this is what we are doing here in answering all these questions. I hope you are able to understand this. And now let's move on to the last question, which is question number 7. Moving to the next question, question number 7. Here we have the question, classify the following sets into finite and infinite sets. That is, we have to conclude whether the given sets here are whether finite sets or infinite sets. Okay, yes. So this is what we are expected to do. Okay, yes. So first of all, let us be sure about what do you mean by a finite set and infinite set. It is going to be very simple. The idea is very simple, that a finite set is one where you can find the number of elements to be a limited one. Yes, okay. You can actually count it. You can very easily count it, and it is what to say? It has got a limit, and it is going to be a sizable number. No matter what size of the number is, it is going to be a small number or large number. It will be a sizable number. Okay, such a set is what you call it to be a finite set. But when it comes to an infinite set, what do you mean by infinite sets? Infinite sets are going to be uncountable. Okay, you can't limit that set. That is, only these many elements are there in that set. In such a way, you cannot limit it. Okay, in such a way, you will have some large sets, right, where you can't tell how many elements are there. So such sets are what you call it to be an infinite set. Okay, so this is going to be the difference between a finite set and infinite set. Okay, a finite set is going to have some limit. Okay, it is limited number of elements. It will have limited number of elements. But infinite set, you will not have limit. Okay, no limit in the number of elements, So maybe a short way I can write like this for you to have a better understanding. Okay, yes. Now we are given question where we have to conclude whether the given sets are finite or infinite sets. This is going to be the task here in this 7th question. So here we have some subdivisions. So let's work them one by one. The first subdivision, it says set A is given by set of all elements x such that x is an integer and x is less than 5. This is going to be the question. Okay, yes. So remember, set of all elements x such that this set is containing all integers which are less than 5. This is going to be the question. Okay, so that means you have to construct this set with elements which are all integers, but at the same time the integer should be less than 5. Okay, so less than 5 in the sense, what can be the extreme number we can have in this set? We can have 4, right? We can very well have 4 to be a number here. Yes, we can very well have, right? Because 4 is less than 5, we can very well have. And also at the same time here it is given integers only, so that means we are not allowed to take any decimal values. That is not permissible. Okay, so 4 we can take, and what other values I can take? I can even take 3, I can take 2, I can take 1, I can take 0 also. But can we stop here itself? Is it possible? No, we can even go for negative numbers, right? Why? Because be clear, x belongs to an integer, right? So that means I can even have -1, -2 and so on. So that means this side it will be continuing without any limit. So in that case, this set we cannot assure exactly these many elements will be there inside that set. In that way, in that manner, we will not be able to give an assurity. So that means this will have infinite number of elements. So that means this is what is going to be an infinite set. Okay, so we'll write it as infinite set. Maybe I can write here. Okay, infinite set. Okay, infinite set. Or for a better understanding, I will write here. Okay, infinite set, IS. I'll write like this. Okay, so maybe we can use this notation, IS for infinite set and FS for finite set. We can write like that. Okay, yes. Okay, yes. So since it is infinite set, of course we cannot get what is the cardinal number of that set. That is also not possible, right? That's why. Okay, yeah. Next, come to the second subdivision. Set A contains all elements x such that x belongs to the set of whole numbers. What do you mean by whole numbers? Whole numbers are going to be 0, 1, 2, 3, 4 and so on. Okay, yes. Yeah, that is going to be the set of whole numbers, and x is divisible by 4 and 9. This is what is given here. So now what do you mean by x is divisible by 4 and 9? You can take any number, but it should be divisible by, you can take any whole number, but it should be divisible by both these numbers 4 and 9. So that means what numbers we can take? We can start from 0 itself, right? I can very well take 0 also, because 0 is 0 I can divide by 4, 0 I can divide by 9. Answer will be 0 only, right? What next number we can take after 0? Which number will be divisible by both 4 and 9? Can you think of? Can you take 12? Can you take 15? Can you take 18? Will these numbers be divisible? No, not possible. So I can go for 4 9s are 36. That 36 will be the next number that will be divisible by both 4 and 9. You can even check it, right? Why I am telling 36? It's very simple idea. The LCM of these two numbers 4 and 9 is going to be 36, and that's the reason I just took 36 to be the next number. Between the 0 and 36, no number you can find such that they are divisible by both 4 and 9. Remember, both 4 and 9. Okay, why? Because they are given x is divisible by 4 and 9, both of them. Okay, both we have to take. Okay, you can take 8 itself, or you can take 12 also, but this 8, 12, they are divisible only by 4. And also I can take 9, I can take 18, I can take 27. Those numbers are divisible by 9 but not by 4. Okay, so they are divisible by any one of them and not by the other. But which number is divisible by both? It is 36 only, right? Okay, yeah, 36 comes. And what about the next one? Now hereafter you can easily tell what will be the next number. Hereafter we can list all the multiples of 36. Okay, so 36 ones are 36, 36 twos are 72. So after 36, 72 will be the next number which will be divisible by both this 4 and 9. Okay, for a hint, let me even write and show you. Okay, so you can take the multiples of 36. 36 ones are 36. Next number will be 36 twos are 72, and next number will be 36 threes are what it will be 108. So it will be the next number 108, and next number will be 36 fours are 144, and the list will be going. And do you think that you can limit this set? Can you limit it? You are allowed to take any whole number, right? The whole numbers will be going and going and going. You can't limit it here also. So in that case, here also this set again an infinite set only. So we can write as infinite set. I hope you are able to understand the point. Why? Because like you can write the numbers like this and it is possible to continue and go. Yes, we can't stop anywhere, right? In that case, you can just stop it here itself. I mean, like I can just put a dot and put here itself, and I am concluding that this set is an infinite set. Okay, all right. Now come to the third subdivision. Here we have set P that contains set of all x such that x is an even prime number which is greater than 2. So what is the set? What about this set? This set is nothing but this contains set of all x such that x is an even prime number. And what about an even prime number? Even prime number is going to be, we know that the only even prime number is 2. And do you think that after 2, that is more than greater than 2, do we have any even prime number? After 2, I mean more than 2, we have the other prime numbers as 3, 5, 7, 11, 13, 17, 19, 23 and so on. This list will be going and going. But check whether at least any one of those numbers is going to be an even number. No, it is not an even number, right? None of them is going to be even number, right? So that means x is an even prime number greater than 2. This set will have what elements? This will not have even a single element. This is going to be an empty set. Okay, so it's an empty set. In that case, this is again a finite set only. So empty set is also a finite set. You can count it, right? So that means this is a finite set. Okay, don't conclude that this is infinite. So this is empty. Although it is empty, you can count it, right? You can easily count how many elements are there. For an empty set, the cardinal number will be what? We have already seen an example also. So the cardinal number for this set will be equal to how much? It is 0 only. That's it, finished. Right? Okay, because there are no elements there, right? That means this set contains 0 elements. That's all. Okay, so this way we can conclude. Okay, fine, all right. I hope you're able to understand the first 3 subdivisions. We'll continue the next one. Next is fourth subdivision. Here we have the set F. F is equal to set of all elements x such that x belongs to a natural number, x is a natural number, and x is a factor of 84. That is, here they are coming to discuss about the set of all factors of 84. Okay, yes. So that means this set contains set of all factors of 84. We already discussed in previous questions also how we can easily collect the factors of a number. Okay, yes. So here our number is 84, right? So let's use the same technique. Okay, I'm going to take 84. I'm going to factorize this 84 in all possible ways. So I think I can do it like 1 into 84. This is one way. Next we can have 2 into 42, this is another way. 3 into 28, I think 3 28s are 84 only, right? So it will be 60 and 24, yeah, yes, of course. And next we can have 4 into 21, this is another possible way where we can factorize. And we can't do with 5 tables, that is not possible. Again we can try 6 tables, right? 6 into 14, 6 14s are 84, this we can try. And we can even go for 7 tables, right? So you can go for 7 12s are 84, that is also possible. Next we can't take 8 tables because 84 we can't divide by 8, that is not possible, so 8 is not a factor. 9 tables also not possible, 10 not possible, 11 is not possible. Next we can go for only 12 tables, okay, 12 sevens are. But the 12 sevens are will be again like repeating the same thing. Okay, so in that case, this set will contain what elements? So this list of elements only we will have for this set. Okay, so that means this set contains what elements? 1, 2, 3, 4, 6, 7, 12, 14, 21, 28, 42 and 84. So I think I have completed all the factors, right? So that means no doubt this set is going to be what set? Is it finite or infinite? you got countable numbers of elements inside this set. That means no doubt this is a finite set only. And what about the cardinal number? How much elements you have here? What is the cardinal number of this set? So clearly there are 12 factors, right? There are 12 numbers present here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 numbers here. I think you can easily visualize it here. It's 6 plus 6, there are 12 numbers, right? So that means 12 is going to be the cardinal number of this particular set. Okay, yeah, done. Coming to the next subdivision, fifth subdivision. Here we have set B defined as set of all elements x such that x is a 2-digit number. X is a 2-digit number, sum of whose digits is 12. This way they have defined. Okay, so now we got a similar question just before. If you see, we have got a similar question, right? 2-digit number and whose sum is so and so. In that same way we happen to get a question. Now in the same way here also we are getting a question, but here we have x is a 2-digit number, sum of whose digits is 12 we have. Okay, so that means we have to take a 2-digit number in such a way that sum of the digits should be equal to 12. In that way we have to take. Okay, yes. So in what way we can take? Can we start from 1? Is it possible? I mean, like can we have the first digit to be 1? So we can't have like that, right? So 1 not possible, 2 not possible. I think you can have 3. 3 is possible. The first digit of our number is 3, and this 3 plus what digit will give you 12? It will be nothing but 9. So that means my first 2-digit number that will satisfy this condition itself will be this 39. All right. So 3 plus 9 is 12. So 39 is the first number. Next, what number we will have? Next will be after 39, which number we can have? We can have 40s. So 40, which number we can have? It's very easy clue. When you increase this first digit by 1, the second digit will be decreased by 1. Okay, so as to compensate the total. All right, so it will be 48. I think I can follow the same pattern. Next will be 57. 5 plus 7 will be 12. You can easily verify. Next I can have 66. I can have. Next we can have 75. We can have. Next 84. Next we can have 93 also, correct? So these are all the possible numbers we can have. So 93 will be the last 2-digit number satisfying this condition. So that's it. So only these elements you will have inside this set B. All right, okay. That means set B, you have these many elements, and this is going to be the structure of this, the elements, the set of the collection of these elements. Okay. So in that case, no doubt, set B. This is also a finite set only. And what about the cardinal number? Cardinal number is going to be how many elements? You can count and see. So there are totally how many elements? There are 7 elements here, right? So cardinal number will be 7. Yes. So I can check it 1, 2, 3, 4, 5, 6, 7. There are 7 elements. So 7 is going to be the cardinal number. All right. Okay. Yeah. Coming to the next one, subdivision number 6. Here we have set C is equal to set of all elements x such that x is a whole number. X belongs to the set of whole numbers. W we have. Be careful. Set of whole numbers. What do you mean by whole numbers? Whole numbers means we can start from 0. Okay. So 0, 1, 2, 3 and so on. This is the way we will have the set of whole numbers. Such that, and the condition again another condition we have, 3x minus 7 is less than or equal to 8. So this is another condition we have. So x is a whole number, and at the same time 3x minus 7 should be less than or equal to 8. So satisfying this condition, what are all the elements we have, we will just check it. Okay, and we will also see whether we have finite number of elements here. Okay. So in that case, what we can try is, we can even try from 0 itself, right? Because 0 is the first whole number. So we can start from the least possible number itself. So try putting x as 0 here. What will happen? 3 into 0 minus 7. The answer will be what? 3 into 0 minus 7. The answer will be minus 7 only, right? It is less than or equal to 8. It is correct only, right? Minus 7 is less than or equal to 8 is a correct condition only. So that means you can surely have 0 in this set. Now check this next number 1. Can you check for 1 here? Can you take x as 1 here? If you take x as 1, you will have 3 1s are 3, 3 minus 7. So 3 minus 7 will be minus 4. Yeah, again it is satisfied. So 1, it can come here, no problem. What about 2? Can you take x as 2 here? So if you take x as 2, 3 2s are 6, 6 minus 7 will be minus 1. Yeah, that is also satisfied. Next we have 3. 3 3s are 9. 9 minus 7 is 2. That is also satisfied. Next, try with 4, the next number. So 3 4s are 12. 12 minus 7 will be 5, that is also satisfied. So yeah, 5 is also less than or equal to 8 only, right? So as long as this expression is giving you an answer less than or equal to 8, you can proceed. Okay, next is 5. We can go for 5. 3 5s are 15. 15 minus 7 is exactly 8. 8 is less than or equal to 8 is also satisfied. That means we can even have 5 also. And what about the next number? Next number, if you go for, you will have 6. So 3 6 are 18. 18 minus 7 will be 11. So here we are getting broken. Okay, the condition is breaking here. So that means we can't proceed further. 5 is going to the last number. It is going to be the last number of this set. So you will have only these elements inside this set. So that means here this set is also a finite set. Okay. And what about the cardinal number? Cardinal number of this set is going to be how much? 0 1 2 3 4 5. Don't put 5. There are totally 6 elements here. So answer is 6 is the answer. Okay. So yeah, successfully I completed up to this subdivision. This is also over. Yeah, let's now continue the next other subdivisions. Next we have subdivision number 7. Here our question is set of all x where x is equal to such that x is equal to 5n and n belongs to the set of natural numbers. That is, n we can take only natural numbers and x should be less than 20. Okay, so here the condition is set of all x such that x value is given in terms of n. X is equal to 5n they gave, where n is allowed to be a natural number, and this x also should be in such a way that x should be less than 20. Okay, that way only we can take. Okay, fine, all right. So in that case we will try to see what elements we will have inside this set. All right, okay, yeah, fine. So if you try to do so, we have to first of all start from the value of n only. N is belonging to the natural numbers, set of natural numbers, right? So that means n we can start from 1, correct? Because natural numbers, we have to start from 1, 2, 3, that and so on, right? So we can take n as 1 first of all. Try putting n as 1 here, because if you know the value of n only, we can tell what is x, right? So 5 into n I am going to take as 1. So 5 ones are will be 5. So that means we can have the first element to be 5. We can very well have it to be 5. And also we have a condition, what it says, x should be less than 20, correct? Okay, yeah, is this 5 less than 20? Yeah, it is less than 20 only. So that means very well we can have 5 inside this set allowed. Okay, yeah, next what we can take? We can take n to be the next number. I can take n is equal to 2. If you take n is equal to 2 means you will have 5 2s are 10. Yeah, 10 is also less than 20. That means 10 is also allowed here inside this set. Next we can have n is equal to 3. 5 3s are will be 15, and 15 is also less than 20. So we can have 15 also. So no problem. Next we will have n as 4. If you take n as 4, you will have x to be equal to 5 4s are 20. But is that allowed? No, it is not possible. We can't have x to be 20 because condition says x should be less than 20. That means we can stop it here itself. That's it. Okay, we'll end the set here itself. And no doubt here, this question also, this set is also a finite set only. So let me just highlight and show you finite set. And what about the cardinal number of this set? Cardinal number is going to be, there are 3 elements. So 3 is going to be the cardinal number of this set. Okay, yeah, coming to the 8th subdivision, here we have set of all x such that x is equal to 5n. It almost looks like the same. Okay, x is equal to 5n, but here n belongs to the set of integers. N belongs to integers, so that means I can take any integer value for n, and here also the condition says x is less than 20. All right, okay. So now let us try to see what elements we will have here. Okay, now first of all we will see whether the elements we had in the previous question, whether they are allowed to be here. We'll just first of all check that one here. Okay, all right. Yeah, if we try to do that, yeah, we can very well have these 3 elements also here, right? So we can very well have this 5 here, 10 here, 15 here. Why? Because if you take this n as 1, you will have 5. If you take n as 2, you will get 10. N as 3, you will get 15. And you are allowed to take n to be 1, 2 and 3. Everything is allowed because n is an integer here. That's the reason. Okay. But n is an integer here will include 0 also. And it will include negative numbers also. Is it or not? So in that case, I can even take n as 0. If you take n as 0, what happens? You will have 5 into 0 to be 0. And that 0 can also be accommodated inside this set because 0 is still less than 20. Correct? And also, I can even take n as minus 1. Minus 1 also I can take, right? Because minus 1 is also an integer. And now if you take the value of x, x will be 5 into minus 1, which will be equal to minus 5, and that minus 5 also I can take here. You agree with this? Minus 5 also can be accommodated. That can also be placed inside the set, because minus 5 is also less than 20, no doubt in that. So in that case, if I try to take all the other negative numbers also, like I can take n as minus 2, n as minus 3, minus 4, minus 5, any value I take, I can find all possible values of x, where all of them are allowed to be placed inside this set. So that means this negative side can be filled in infinite ways. Okay, that means I can fill infinite number of elements here in the negative side, but the positive side we have a restriction only up to this 15. Why? Because if I try to go beyond this 15, we are getting numbers which are equal to 20 or greater than 20. So that means we can stop here. But here this side there is no restriction for negative numbers. Negative numbers we can have any number of values. Okay, as long as I am going to take values for this n, like minus 1, minus 2, minus 3, minus 4 and so on, I can keep on getting values for this x, and all those values are allowed to be inside the set, because this x is less than 20. All the numbers are going to be less than 20 only, obviously, right? So that means this set we can't limit with the number of elements. So this is going to be what? This is going to be an infinite set, and hence obviously we can't get what is the cardinal number of this set. Okay. Yeah, okay, fine, yes. And we have the last subdivision here, subdivision number 9. Let's see what question we have here. Set of all x such that x is equal to n by n plus 1. Be careful, x is equal to n by n plus 1. X they are giving to be the expression to be equal to n by n plus 1, where n belongs to whole numbers. Whole numbers means, properly, carefully remember the set of whole numbers. Whole numbers will always start from which number? It will start from 0. So 0, 1, 2, 3, 4 and so on. Okay, that's how it goes for whole numbers, and n is less than or equal to 10. This is what is given here. So in the case, how will be this set? Shall we try to frame this set? So since n is going to be a whole number, we will start from the least possible value itself. That is, we will start from 0 itself. So if you take 0, what happens? If you take n is equal to 0, then what will happen? We will have x to be equal to 0 divided by 0 plus 1. What happens? I am not writing and show you. I am not going to complicate it much. Take n as 0. Simple substitution, right? N is equal to 0. If you take, it will be 0 by 1. Obviously, that's going to be 0. That means the first element we can have here inside this set is going to be 0. Okay. What next I can take? I can go for the next number. N is equal to 1 I will take. So if I take n is equal to 1, I will have what? I will have 1 by 2. Is it or not? Just substitute n equal to 1. Wherever n comes, you put 1 here. So I will have 1 by 1 plus 1. That's nothing but 1 by 2. Is it or not? So the next number I will have is 1 by 2. Continue like this. Okay. If you take n as 2, you will have what? 2 by 3. Next you will have n as 3 as 3 by 4. If n is 4, you will have 4 by 5. Next 5 by 6, 6 by 7, 7 by 8, 8 by 9, 9 by 10 we can have. And what next we can have? We can even take n as 10 also. Up to n equal to 9 I took. When I take n equal to 9, I am getting 9 by 10. We can even take n is equal to 10. Why? Because n is less than or equal to 10 they have specified, right? So we can even take n is equal to what? We can even take it to be 10. So if you take, like, we will have what? 10 by 11. So 10 by 11, up to 10 by 11 we can have. But can we go beyond this? Is it possible to go for the next value? No, it is not possible. We are not allowed to take values for n more than 10, because n should be less than or equal to 10. That's what is specified. So the last entry, the last element that you will have inside this set will be this 10 by 11 only. So that means this is going to be the set of elements we will have in this set. Okay. So subdivision number 9. So you have this set to be the answer for this question. So that means obviously this is also a finite set only, because we have limited number of elements, right? So it's going to be a finite set. And what about the cardinal number? Cardinal number of this set is going to be what? It's very easy for us to check, right? There are totally how many elements? There are 11 elements, right? Because 1, 2, 3, 4 up to 10 is there, and extra 1 0 is there. So totally 11 elements are there in this set. So cardinal number of this set is going to be 11 is the answer for this one. Okay. Yes. Fine. I hope yes, all the questions of this exercise is being completed. Yes. So for this 9th question also we have completed up to this one. So everything is over for this exercise. Yes. Yes, all of you, I hope you are able to understand the way how we solved each and every problem here in this exercise. I hope everything is clear to you, and if at all you got any doubts, you are most welcome to comment it in the comment box, and if I see, I'll see to rectify your doubts. And as usual, if you feel that this session is helpful for you, please give a like, and also if you feel this would benefit any of your friends, please do share this video to your friends also, so that they can also see the way how it is solved, how the problems are solved and everything. And if you feel this channel to be useful, please subscribe to our channel, and again we'll catch up in the next session with some other exercise or problem solving. See you soon there. Thank you so much.